Hi everyone. So this is an extension of what you did yesterday with the rational root theorem and finding zeros with synthetic division. I'm also going to go over one of each type of the practice problems from your assignment that I want you to work on today and tomorrow, so that way you kind of know what you're doing. So picking up from where we left off yesterday, we already did the synthetic division on both of the roots that I wanted to test. So since you got a 0 as your remainder, that means that number that you are dividing by is a root. And if you flip the sign of that number and attach it to an x, it becomes a factor. So going back to yesterday, if I tested x is equal to 1, that means that x minus 1 is a factor of this polynomial that's up here. X equals -2 is a root, which means that x plus 2 is a factor of that polynomial that's up there. So for part 3, where it asks you to write in factored form, the two factors that you already know are x plus 2 and x minus 1. The remaining factor is the result that you got from your synthetic division here. So if I were to write this out, originally your highest exponent was a 3. So that means now it gets knocked down to a 2. So this answer would be 6x squared minus 11x plus 4. So that is also one of the factors. My issue though is that all of the factors that I get need to be linear, meaning that I can't have any x squared components. So I'm going to take the x squared component, so this expression here, and I'm going to factor it. So a times c at the top, b on the bottom, 6 times 4, 24, and then -11. So I need two numbers that multiply to 24 and add or subtract to -11. Those two numbers are 8 and 3, and I need both of them to be negative to satisfy my conditions. So I'm going to do double distribution, but if you want to use the box method to factor this, you can do that as well. So I'm going to take 6x squared. I'm going to break that middle term into the two factors that I have here. And then break it off into two groups. And take out your GCFs on both sides. So between the 6x squared and the -8x, the biggest thing that they share is 2x. 6x squared divided by 2x is going to get me 3x. And then -8x divided by 2x is going to get me -4. On the other side, whenever you see a negative sign in the front like that, you always want to take it out. So I'm going to take out a -1, and then the signs on the inside of the parentheses are going to flip. So I'm going to get a positive 3x and a -4. I know I did it correctly because my terms are matching. So one of your factors is that matching term, and the other factor are the GCFs that you took out. So you've got 3x minus 4 and 2x minus 1. So when you write it in factored form, you have these two factors that we just found, in addition to the other two that we found from synthetic division. Okay, So that would be your factored form. Okay, this is your practice assignment. For the first 6, you're only listing the possible roots. You're not going to use synthetic division to test them. I just want you to make me a list. So for example, for number 1, this is P. Your Q is going to be a 1. So you're going to do X is equal to plus or minus P over Q. So plus or minus 6 over 1. And then you can set up the box and you can list out your different factors. So the factors of 6 are going to go on the top and the factors of 1 are going to go on the bottom. So I'm going to have 1, 2, 3, and 6. And then the only factor of 1 is just 1. So you have plus minus 1, 2, 3, 6. And remember, this is the top of your fraction, and this is the bottom. So this one's pretty easy. Since you're just dividing everything by 1, nothing is really going to change. You're just going to write it like that, okay? If they do have something other than 1 on the bottom, you just divide those fractions. If they repeat, you don't have to list them twice. So you're just making me a list, and you can leave it in a box form if you want to. That's all that you're doing for numbers 1 through 6. Okay. All right, on the next one, you are going to find the y-intercept, write it in factored form, find the roots, and sketch a graph. So this is similar to what we were doing before, where you need to do synthetic division given the possible roots. So I'll do number 7, for example. Okay, so your y-intercept, that's just this number. This is your y-intercept. This is also P. For this one, your Q is 1. So your y-intercept is at 0, negative 18. And then for your factored form, I'm going to make my list of possible roots. So, whoops. You can just put 18. You don't have to worry about the plus minus sign when you're finding the possibilities. So you have plus or minus 1, 2, 3, 6, 9, and 18 all over, plus or minus 1. The life hack on this one, if you were to sit there and check all of these roots with synthetic division, it would take you like multiple days to do this, and that's not the point. Graph the original equation, so this one here, graph that in your calculator, and then if you go to menu, trace, graph trace, you can scroll side to side and it'll pop up with the word 0. A 0 is the same thing as an x-intercept, is the same thing as a root. So I graphed mine in Desmos. You can use Desmos if you want to. The roots that I found, so these are from your calculator. You can rewind the video to hear the calculator instructions again. You should get negative 90, negative 20, and 10. Okay, so that means your factored form, you're just going to flip the signs of the roots that you see there. So you'd have x plus 9, x plus 2, and x minus 1. And that would be your factored form. Okay, so don't go through the heartache of doing all that synthetic division. Put the original equation that I've highlighted up here into your calculator in the graph. Go to Menu, Trace, Graph Trace, scroll side to side, not up and down, but side to side until your calculator says the word 0. When it says that, that is one of the points. So you're looking for all the places where the graph crosses the x-axis. You can also use that picture on your calculator to sketch down here what it looks like. I already listed the roots up there, so I'm not going to list them again. This can be a super rough sketch. You know, my sketches are always terrible. So here, -9, -2, and 1. I'm just using those points that I had above. Looking for your end behavior, your highest exponent here is a 3, and your leading coefficient is a 1. So this is an odd degree positive. So the right end is going to be facing up, and the left end is going to be facing down. So the right end is going to be going up. The left end is going to be facing down. And then you can just kind of trace the shape that your calculator gives you. So it's going to look something like that. It doesn't have to look exactly like that, but as long as it looks remotely like that, that's what I'm looking for. Okay, so that's what you're going to do for 8, 9. Yeah, it is. Okay, cool. 10. And then I think that's the end of the assignment, right? So that's what you're working on for today and tomorrow. I am going to post another video tomorrow, and it'll be the notes over increasing and decreasing intervals. I'll post like a hard copy answer key of that on the Google Classroom as well, so you can use that to check. And then I will hopefully be back on Monday. So this practice assignment is due Friday, but other than that, there's nothing else that you should need to turn in, okay? Please email me if you have any questions. Thank you. Number 4 wants us to identify the roots as points. So I'm going to take my factored form, and I'm going to use that to solve those 4 different factors for x. So you're basically going to take each one of these factors and set them equal to 0. And then you're going to solve for x on all of them, and that should give you your roots. So here you're going to get x is positive 4/3. So as a point, that would be 4/3, 0. On this one, you're going to get x is equal to positive half. So that would be 1/2, 0. Here, you're going to get x is equal to -2. So that would be -2, 0. And here, we're going to get x is equal to 1. So I'm at 1, 0. When it says identify the y-intercept, that is just the p-value. And our p-value, if you look back at like the very original equation, like the 6x to the 4th, whatever, our p-value is -8. So your y-intercept is going to be at 0, -8. So you're going to use all of these things to help you graph. So our last step, step 5, is identifying the end behavior and then drawing the graph. So your original equation, I'll just write it out again. Okay, so this was your original equation. Your type of function, since your highest exponent is a 4, it's even, which means that both ends of the graph are going to point in the same direction. Your leading coefficient, or your A value, is 6. That's a positive number. So that means that the end behavior of my graph is going to have both ends pointing upwards in the same direction. So like this. So I'm going to use my y-intercept, my x-intercepts, and my end behavior to help me graph it. So I'm going to go ahead and plot my x-intercepts. So 4 over 3 is like a little bit bigger than 1. So I'll put that one there. A half, -2, and 1. Oh, let me zoom this in. Okay, let's try that again. Okay. 1. Okay, so this is my 4 x-intercepts, then my y-intercept is like way down here somewhere at -8. All of these are single roots, so they all cross the axis. None of them are going to bounce. So you're told that in the problem. I'll tell you that in the other problems as well if you were to get this on a test or something. So they're all going to just cross through. They're not going to bounce. So I know at the ends of my graph, I'm pointing up in the same direction. So from these last x-intercepts, I'm going to go up in the same direction. And then I'm just going to connect the dots, and I'm going to cross through every time I hit another point. So cross, cross, cross. So that is what my graph looks like.